Hello everyone. So today we are going to discuss Bitwise Complement Operator. I was not able to find any useful tutorial regarding this operator, so I explored it, and in the documentation it simply says that we are getting the bitwise complement of the operand that we use it on. In Geek for Geeks also it specifies that it takes one number and inverts the all bit. So I created an example for you. So let's say we have an integer x. So we can simply get the complement using the tilde operator like this. So I will print it for you. So you can see that it shows 11. So now let's quickly see the what should be the output. So let's say we have 10 here. The 10 represents 1010 in binary. So basically 10 to the in decimal is equals to 011010 in binary. Now if you do not know about the binary format or for binary number system, you can check out the videos provided in the description. So basically this is the case that the 0th bit is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, and this is 2 to the power 3. So that would result in basically 0 1 2 3. So this would be 8, then this will be 0 because we have 0 here, this would be 2, and this would be 0. So the sum of all this would result in 10. So that is how we represent 10 in binary, right? So basically if we invert all the numbers as it says in the operator, so let's say using tilde, we get 1010 1010, we get 0101, and in binary that should result in this is let's say this is 0, now this is 1, this is 2, 4 and 8. So 4 plus 1, that would be 5, right? Yeah, that would be 5. But the output that we are getting is minus 11 here, right? So that is definitely not nearby. So there is definitely something wrong here. So this is the issue that I was facing as well. So that is why I wanted to discuss this. So basically I have created these two print statements where we are using the inbuilt method in the integer class. So basically we can convert an integer to a binary string to basically get what we are storing in the memory. So let me run it and I'll show you the output as well. So as you can see, for 10 we are getting 1010, and that is pretty much what we were expecting. So we are getting 1010 for 10. So yeah, that is fine. But for the complement of x, that is supposed to be the inverse of all the bits, we are getting minus 11, and we can see that we have a huge number right here, right? So in binary this would be a large number, right? Because these many of 1 means 2 to the power 8, then 12, so on, 8, then we'd be having 16 and 32 and so on and so forth. But we don't see the number here as well because we are getting a small number. It should be a large number as the one suggests. So basically as we keep going to the left, the number should increase. So I'll show you, let's say 1 1 1 1 1. So this should be 1 2 4 8 16, right? So that would be 1 2 4 8 and 16, and the sum of those will be, let's say 16 4 will be 20, and that should be somewhere nearby 31, I guess, right? Not sure, but I guess that is the sum. 16 4 will be 20, and yeah, that is this, and it's right. So but we are not getting the output somewhere nearby, right? Because we have so many ones that should increase, because as we keep on going left from here, I'll show you, as we keep going on left from here, that would totally increase, right? but it is not increasing, right? So as you can see, we have these number of ones here. So the reason why we have it is because in Java we store integer as a 32-bit, right? So int is a 32-bit variable, right? So basically 32-bit means 8 bits 4 times, right? So that is how I would like to represent it. We have 8-bit followed by 8-bit, and that is the four times we follow it, so we get 32 bits, right? Now we can see that the 10, so basically we had 10 which was being represented like 1010. So if we represent it in a 32-bit format, we would be having 8 zeros. So I would be representing 8 zeros like this, 0 and 8, right? So this means 8 zeros followed by 8 zeros followed by 8 zeros, and then we have 4 zeros, right? And then the four these numbers, right? 1010. So this would be 1010. So these are the bits that provided value, and the one beforehand are all zeros. So Java tends to ignore them, and that is the reason why it doesn't show them right here. Okay. Otherwise, there are these many number of zeros behind this as well. So continuing on our topic, so we know that we have these things. Okay. Now if we before we were inverting using only the 4 bits, right? We inverted the 4 bits here, as you can see. We took 1010 and we inverted the bits. But what we would like to do here is that invert this full, right? 32-bit full integer. So to do that, I would be getting all the zeros to 1, right? So that would be 8 ones, again 8 ones, again 8 ones, followed by 4 ones, and then we will invert this. So 1 will be 0, 0 will be 1, 1 will be 0, 0 1. So that will be the scene, and these the 4 last digit would signify 6 here in the case, right? And that would be the inverse for us, right? And we can pretty much see that this is the case here, right? So the last 4 bits are 0101 as we were expecting, as you can see, right? But the value that it infers from it is totally different, right? It gets minus 11. However, we are taking only 6 here. If we take into account these numbers along with these 24 bits that we have here, it would be a totally large number, right? So I'm not considering them right now, but it should be definitely in the positive side as well. I would like to add that as well. So we will clarify that as well why it is negative, right? So if you might be familiar, we have 32 bits just like I mentioned, right? So 8, 8, 8, and 8. So these are the most significant bit. So towards the end, these are least significant because it basically moves from 0 then 2, 4, and so on till the last one. That will be 32, right? And 32, not the 32, but 2 to the power 32. Okay. So we can represent it also like this: 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on, right? So the least significant is towards the left. So the most significant is towards left. Yeah. Yeah, I would like to add also that we know that integer can store a certain set of values, right? So let me open the documentation for you. Let me go to the integer types, and you can see that in integer we can store from this value to this value. So I will zoom in for you, right? So yeah, these are the values that we can include in an integer, and I will show you that 2 to the power 32 is definitely more, right? it is somewhere in the 4 digit, but here we can see we are having 2 digits, right? That is because the last digit is being used for showing whether the digit is negative or positive. So if we now use 31, so because we have lost one digit, one bit you can say, so that results in 21474836448, and you can see that is pretty much the case here, right? So basically what I wanted to mention is that 8 bits here, from the 8 bits, one bit is being used for sign, right? One bit is for sign, so this would result in only 7 bits. So these results in 31 bits, right? One bit is always reserved for sign. In that case, we can see here that we had 8 zeros, right? So it will be very much safe to say that we have 7 zeros. 1 zero I'm differentiating because this is a sign thing, right? And 0 represents it is a positive number. Meanwhile, 1 represents it is a negative number. So here also I can say there are 7 ones, and the separate one is for sign, right? So 1 1, and that is a sign thing. Okay, so now I can see that we will be having here, right? Here we will be having, let's say the number that we are storing now will be 0, no wait, 1 7 times, 1 8 times, 1 8 times, and 1 1 1 1 0 1 0 1, right? And that is pretty much the number that we see here. It does not have 32 digits but 31 digits, and I will show you that as well so that you don't go searching later on. So it has 32 characters, right? And the one is for sign, the first one is for sign. Okay, so don't need to worry about that. The first one is for sign, and the remaining these are in order to determine the value, right? So coming back to the here, so why we are getting minus 11, right? That is the question. Even if we have this thing here, so that should result in a pretty much big number, right? Because 2 to the power 31 also is a quite big number, and surely greater than 11 for instance, right? Minus 11 for instance, yeah. So the issue with this is that in Java it stores it as this only. Okay, so we can see that it stores it in this format by printing it. So we saw that it is storing it correctly, but what the issue is that when it reads a negative value, so I will add that here as well. So when Java reads a negative value, it simply takes 2's complement of the number. So negative value, it returns the 2's complement of it, right? So what do I mean by that? So we have this number right here. Okay, so just like we saw, 7 ones, 8 ones, 8 ones, followed by 1 1 1 1 0 1 0 1, right? So how to get the 2's complement if you don't know it? So to get the 2's complement, we first get the one's complement, and which is basically inverting the bits, right? Basically like the not operator or the tilde itself, right? And the second step is to simply add one, right? So if I take this example, right? So we have 1 sevens, 1 eights, 8 ones, 8 ones again, 1 1 1 1 0 1 0 1. So first step will be getting the ones complement, which is simply inverting it. So 0 sevens, 8 zeros, 8 zeros, 0 0 0 0 1 0 1 0, and the second step would be adding 1. So obviously we'll be adding 1 towards the right and not towards the left, because that is basic maths, right? So basically let's put the second here. So in this binary, if you add 1 with 1, you get 1 0. When you add 0 plus 1, you get 1. 1 plus 0 also 1, and 0 plus 0, you get 0, right? So these all things will be value will be 0. So basically we can say 0, and we can simply say all these things will be 0 here, right? So we can say these all things will be 0. Leaving those aside, we are going to add this 1 plus 0. So as we discussed, it is going to be 1. So 1 1 0 1. So that would result in simply 7 zeros, 0 8 zeros, again 8 zeros, then 4 zeros followed by 1 0 1 1, right? And if you convert this whole to decimal, that would simply result in 11. And don't forget that we also had a sign bit, right? So the sign bit is 1. Still it is 1 because it is a sign bit, and we are not supposed to cause any bit change to it, right? So Java knows that it is a negative value, so it will return a negative value. So that results in minus 11. So that is why it returns minus 11. And I hope that you liked the basic explanation. You can dive more into it though, and explore the uses of this thing in the documentation. But so far I was not able to find any useful information regarding how to use it. I would love to know how to use it down in the description. If you need this PDF, let me know. But yeah, sure. And find more links in the description. So yeah, that's all. Thanks a lot for watching.